IBM and NASA launched Surya AI to predict solar storms with greater accuracy. IBM and NASA have introduced Surya, an open source AI foundation model built to forecast space weather events, particularly solar storms, with higher accuracy and resolution than traditional forecasting systems. The model is trained on 9 years of data from NASA's Solar Dynamics Observatory, forming the largest curated heliophysics dataset to date. Surya processes solar imagery at a scale 10 times larger than what most AI models handle, thanks to a custom multi-architecture setup designed to handle massive, high-resolution input efficiently. This allows it to predict where solar flares may occur up to 2 hours in advance, marking a significant leap in visual solar forecasting. Initial performance benchmarks show a 16% boost in classification accuracy over previous methods, suggesting stronger early warning capabilities for mission-critical industries like aviation, satellite operations, and grid management. Kevin Murphy, NASA's Chief Science Data Officer, said, "We are advancing data-driven science by embedding NASA's deep scientific expertise into cutting-edge AI models. By developing a foundation model trained on NASA's heliophysics data, we're making it easier to analyze the complexities of the sun's behavior with unprecedented speed and precision. This model empowers broader understanding of how solar activity impacts critical systems and technologies that we all rely on here on Earth." The move toward open access, Surya is available now on Hugging Face, also expands the potential for international collaboration and innovation in space weather mitigation. Why solar storm forecasting is becoming a business imperative. Solar storms aren't just a scientific concern, they're a mounting economic risk. Recent events have already disrupted aviation routes, GPS services, and satellite operations. Analysts, including those from Lloyd's, estimate that severe solar activity could trigger up to $2.4 trillion in losses over 5 years if critical infrastructure fails to prepare. For businesses that depend on satellite connectivity, GPS-enabled logistics, and real-time communications, the ability to forecast space weather events is becoming essential. Power grids, in particular, are highly vulnerable to geomagnetic storms, while airlines face radiation risks for both passengers and crew. By launching Surya, IBM and NASA are not just advancing scientific capability, they're laying groundwork for commercial use cases. From precision agriculture to autonomous transport, the opportunity to minimize service disruption could give organizations a tangible competitive edge. The release also fits into IBM's broader strategy under the Prithvi model family, which includes foundation models focused on geospatial and environmental forecasting. While the business impact of space weather has been underexplored, this development signals a shift toward treating solar resilience as part of digital risk management.